Now let's see something called variable scoping in JavaScript. So in JavaScript, whenever we create some variables, let's say using let or const, those variables are something called block scoped, which means that if I am creating, let's say I am writing some function, right? Then inside this function, let's name this function something ASD or whatever, or foo. Now inside this function, when I'm writing anything, so let's say I am creating a new variable, let a is equal to 5 or something. Now this this thing this thing is only available in the scope of this function, and that's why we say that any variable which we are declaring using let and const are block scoped, which means that the scope, the region in which this variable is visible, is only inside this block, you see. So if I do something like let's say log a, and I do foo, then obviously this thing is 5 that is printed. But after that, if I again print a here, then you see that error will happen. So first time this 5 has printed inside, but after that when I'm trying to access a outside this block, then we see that reference error a is not defined, and that is because a is not defined in this outer scope. A is defined only in this scope. A is defined only in the block, this block, which is a block of code which is there, and that's why we are writing here that let and const are block scoped variables. Now there are other kind of variables which we briefly discussed earlier, something called var, which I told you never to use it. So they are like somewhat more complicated. So even if you declare it in block, it is available outside. But again, that is confusing and that is a bad practice. That's why we are not even going to discuss those things. We are always going to declare our variables using let and const, and for our purposes let and const are always block scoped. But when they are declared inside block, then only they are block scoped, right? If I declare let's say this a outside, it is not inside any block, then it is no more block scope, because there is no block, right? So it is like globally defined, and that's why when it is not declared in any block, then it has a global scope, which means that now a can be accessed from function also, from this outside also, anywhere. And when I print now, I see that 5 5, this is also correct, this is also correct, because it is outside, so everything can access this a, right? And this is the example which I was giving, that it can when you declare something inside, then only it is declared available inside, but outside it is not accessible. However, when you declare it outside, then it is accessible from anywhere. However, uh, it's not that only function blocks are there, right? Let's say I have written something like this, that let's say if and let's say some condition which is like let's say 5 less than 10, which is always true, right? Or I can directly write true also. So means I want to execute this block always, so that is fine. And let's say here I define this let, and I print a. So again here also the same issue will happen, that first time this a is printed and a is not, which means that there are many types of scopes, many types of blocks. It's not that only a function block is there, this is also a block, this is also a block. In fact, if you write something like if you write in fact something like this also directly, then also there is a scope. This is like um, sometimes it will not make sense that why I am putting it in curly braces. So this is a syntax in JavaScript where if you simply have curly braces, then also you can use that. The purpose of that is that if I write anything inside that, that thing will not pollute, and the term used is pollute, that will not affect the variables outside it. It will be separate, it will be a completely new variable if you declare anything inside this. And that's why again here also you will see the same problem, that here 5 is running fine, but you cannot do something like this here, right? But again, if I would have done something like here, then obviously it would be fine. It would be fine. Okay, so foo is not at all declared. Okay, you see, this was 5 5. This was working fine. But if I do something like this, then you see that this 5 was running fine, but the second A is not defined, it is saying. Okay, now there are again just I give you an example of this block, right? Again you can see that if, else, if, all things. So let's say I write something like, if let's have a variable, so let's say let t is equal to anything, let's say 10. Okay, and I write something like if t is less than 5, if t is less than 5, then whatever you do, something, whatever, let's say print hello, whatever, and this block, let's put it in else. So I'm just trying to give you an example that this thing is also fine, right? So this again, like if is a block, similarly else is also a block. Similarly, if I write else if t is less than 20, this is also a block. Okay, so most of the times whenever you see these curly braces, then you will readily understand that that is a block, and any variable declared inside that is a completely new variable. Okay, and the scope of that variable is only within that block if you have declared it. Now you understand that if I declare some, and let's run it first, so you can see that this a is not defined, right? Because I have declared a inside. However, if I would have declared here, then it is perfectly fine. Okay, not only that, let's comment this out and let's move this inside. That is fine. So obviously only one time 5 will be printed, but you can very well use outside variables inside. So you cannot use inside variables outside, but outside variables you can use inside. So for example, here you see that t I can use here, right? Anyways, this is like not a block, but let me give you an example of some other variable. Let's say x is equal to 50, right? Then you can very well write, let's say a comma x, and it will print 5. A is 5 and x is 50, so it will print 5 and 50. So you can understand that inside this block, x is available because x is available in the outside scope. Okay, so whenever a variable is declared inside that scope, then obviously that is accessible, but any variable which is outside that is also accessible. Now one another thing is that something like we will see later, that this outside variable can also be the same name. You see, outside variable can also have the same name, and this is called shadowing, which we will see later. But just right now I'm just giving a simple example that it will not give you an error. It will still give you, it's just that if you not declare it, then it will say that a is not here in my block, a is not there. So it will check then outside, that is there some variable outside, and outside it can say that, it can see that there is something. So that's why it is running, right? But if this thing is commented, right, then again it will give error because a is not defined, nowhere it can see a. But again, if that thing is not there, again this thing is there, then again it will run fine because in the immediate scope I have got my a. But right now let's not take example of same variable, because same variable is like shadowed. This is the term which we will use later. But right now just I'm giving you an example that any variable which is outside, let's name a different variable, then that is also variable that is also available inside. So a block variable declared inside a block is not visible outside, but any variable which is declared outside, that is available inside. Again, here also if you see that if I write something like again, let's simply write if true, just for simplicity. I'm just trying to create another block, right? In fact I don't need to write if to create a block. I could have simply written only curly braces, but just I'm just writing. Okay, so you can see that again here also it is visible, right? Now in this block a is not there, but outside a is there, and that's why it is working fine. But again, if you see that if you here you declare some b is equal to 10, then this b is only available inside this block, right? So if I write a b x, let's say, right, then it is perfectly fine, 5 10 50. But the same thing if I do here, then again it will say error that b is not defined, because a I can see, yeah, a I can see that in this block is there. X I cannot find in this block, but yeah, I can see that globally x is defined, right? But b is not defined anywhere, right? B is only defined in this scope. Okay, so only you can access it inside scope or again here if you again have another scope inside this, then again you can access. So you get the point, right? So this is called variable scoping. Now just I was discussing something called variable shadowing, where there is the scenario where a local scope means so this thing, so let's say this thing, okay. So this thing, we can say that this is local scope, and this outside is, let's say, a parent scope. You can understand. And if you say that for a variable, this thing is local scope, and anything outside that is like parent scope. You can understand. So parent scope, you can understand that local, you can understand is a child scope or something. So this thing is a child of the global scope. This thing is a child of this scope, and again if you create another scope here something, then this scope is a child of this scope. So we will say, if we declare some variable c here, then we will say that this, for c, this is the local scope, and this outside one is the parent scope. Okay, so the point we are trying to make here is the variable shadowing is a scenario when the variable in the local scope uses its value instead of the variable in the parent scope with the same name. I think I should clearly write here same name, which means that if a variable is there having the same name, and that is what I was explaining earlier, that if I have something like x is equal to 50, and if I have another block and there I have declared x is equal to 10, then you can understand that if I print x, then x will be printed 10, because in this scope x is shadowed. Shadowed means if this would not have been there, then it would be 50. So x was 50 till now, but when I declare another variable in the same scope with the same name, then the new variable shadows the earlier variable, and that's why now this outer x will not be visible. Why? Because it is there, but it was not overwritten, in the sense that that name is now pointing to this variable rather than that variable. So there is no way we can access from here that variable. The only way is that we have to create some other name for this variable x, or we have to create some other variable, let's say y is equal to x I have written, and then I can access x also, y also, right? That is the only way. So 1050 both we are able to access, right? But if only x is there and if x is redeclared, then obviously that is shadowing, and only the locally declared variable will be visible. This is what I am trying to say here, that if a is there, and then if you're inside of let's say if you have a function foo, right, inside that if you are having 20, right, then again whatever this, so we discussed that again, like function is also a block, right? Function is also a block. So if I have a variable let a is equal to 10, and then I create my own new function, you understand, my new own function, and let's name this function something, let's say foo, and this in this function I create another variable with the same name, that because we are trying to give an example of shadowing, right? So and then if I print this a, then obviously if I call this foo, then this will be again 20, right? But mind you that a outside is still 10. It's just that inside this scope, since I have declared a new variable, then now I am not able to see that original variable, and that's why it is 20, because now whatever is the new variable, that only I can see. That's why the variable has shadowed over the outer parents variable, right? This is an example. Okay, and this is an example of directly declaring something, right? But the shadowing also happens if you declare a parameter with the same name. So, for example, let's, rather than declaring a new thing here, let's have a parameter here, n. Okay, n, and we print n here. Okay, then if we call right now, then obviously it will be undefined because we have not passed. So let's pass a, but now it will be 10 10. Now if we do something like n is equal to n plus 1, okay, then you see that what is happening is that this is becoming 11, this is 10. Now this is an example of shadowing, right? Shadowing, okay, so I think for giving an example of shadowing, we should take example of same variable. So let's say this is also n, this is also n, this is also n, and everything is n, because with a different variable we took an example earlier. But right now if you see that if I don't use this, if I don't increment it, and let's say I don't pass also anything, right, then what is happening, that now this n is this global n, and whatever n I am passing here, this is getting discarded because I am not using that, right? So this n is now the global n, and that's why this will be printing n 10, right? So this is also 10, this is also 10. But when I pass n, then what is happening, that this n is shadowing the outside n. So now this n is different, completely different from this outside n, because you can understand, as we discussed earlier, that this n if we are doing, then you can understand that here it is equivalent to let n is equal to, and whatever value this n you pass, what is n? N 10. Then is it equivalent to doing this thing, this whole thing, it is doing inside this only. You can understand for like that. So this n is a completely new variable, and now since it is a new variable, any change you make here, so right now it is 10 10, that is fine. But if you do any change here, then since it is completely new variable, so it only this thing will be affected, this thing will not be affected, and that's why you will see that outside n is still 10, but inside it has become 11. And again, why this is happening? Because it is passed by value. If this would have been object, then that would not be the case. But again, there also the concept will be same, that even if a new variable is created, but that variable is pointing to a reference of the some same old variable, and that's why that changing would have happened. But again, there also this creation of new variable will definitely happen whenever any parameters is there. But the whole thing is that the shadowing not only takes so let's say here, let's say let m is equal to 20, right, and let's print here n comma m. So obviously it will be 11 and 20 will be printed. This 20 is coming from outside. But again, if I declare, let's say m is equal to 50 here, then this is also example of shadowing, right? So what is happening, that this m is now shadowed with a new declaration of m, okay, and now if we run, then we will see that it will be 1150 rather than 1120, because this m is the new one. Note that for shadowing you don't need to completely assign any value, even if like just it's declared and not assigned any value, then also it will shadow. So you see that till now this let m will not be there, till now it will be definitely 1120. As soon as I do something like let m, then it will be shadowed. And shadowed with what value? Shadowed with whatever the value is there, and there is no value. We have not declared any value, just we have not assigned any value, we have just declared m, and by default if you declare and don't assign, then what is the value? Undefined. And that's why you see that inside when I'm console logging, then I'm getting 11 and undefined, right? So for shadowing you don't need to do all those things, right? Similarly, like scoping, we can also have multi-level shadowing also. So for example, right now I can see that, yeah, this is a different m, right? But again, if we have something like, let's say if true, right, and again inside that if we are printing, then till now obviously we are getting undefined or undefined. Let's put it any value, let's say 30. Then this 20 should not be there, this should be 1130 is printed. But let's remove that for now. But again, if I declared again let m is equal to 50 here, then again this m is shadowing this m, and that's why you can see that when I comment it, then that becomes slightly bright, which means that now it is being used. When I uncomment it, that will become slightly dull. You see that has become dull because it is never used. And if you can use it outside, that is fine, you can use it outside. But now you will see that the values printed will be different, right? This is 1150 and this is 1130. Why? Because inside this scope again this m is shadowed, right? And that shadowing thing is 30 is shadowed with 15. That's why 1150 is there, and here 1130 is there. Now note that, let's say I don't use this, then obviously it will be 1130, right? But instead of commenting this, if I comment this, then what will happen? Then you see this m is still shadowing, but now m is not shadowing this m is shadowing this m. So instead of 20, now it will be 50. But what will be this m? Because there is no m now, I have commented this, so no m is defined in this block. So again it will go outside and it will see that if there is any m should be, and if no m is there, then it will give syntax error, variable is not available. But right now it will be running fine with the answer 1150 and 1120, because in this scope m is 50, but in this scope this m is not shadowed, it is simply taking this variable 20. But if this is there, then again this is like first level shadowing. But here again you are here you are shadowing 20 with 30, here you are shadowing 30 with 50. So you can understand that in a similar concept, like any level you can go and this sort of shadowing and all things will work. Okay. Just one more example. When we were trying to see blocks, okay, blocks of this thing, scoping, right? Then we saw that blocks of what? Function blocks can be there, if block can be there, else block can be there, else if block can be there. In fact, we saw that only curly braces you can use. You can use something like only this, right? That is also a block, right? Only this thing, that is also a block. We saw that. But there are other types of blocks also. For example, for loop, right? So let's say I have a for loop. I have a for loop. So for let I is equal to 0, I less than let's say 10 or 5, and I plus plus, right? And here I am printing, let's say I. Now you see that this I is only available inside this for loop. So right now if I am printing, I am getting 0, 1, 2, 3, 4. That is fine. But if I try to access outside for loop, then you see that again it is saying that I is not defined, because this I is only available for this loop. But you could have done something like this. You could have done something like this, that I will declare it outside. And just to tell you, if you're not already aware, in for loop it is perfectly fine to use something like this, that nothing is there, which means that there are two semicolons, right? The first semicolon is like initialization, where something, the second semicolon is the condition for which it is going inside, and third is like whatever additional after each iteration, whatever additional processing you want to do, you can do here, right? But everything is optional, right? In fact, you can write very well a for loop which is something like this, semicolon semicolon, which means that all the three parts are optional. You can do like this also. But what will happen? Let's run this. What do you think will happen if I do something like let's say log and some, let's say something I have printed? What do you think will happen? You see, it will go in infinite loop. You see, it is going in infinite loop. Okay, if infinite loop, you are stuck in infinite loop, please press I believe Control C on your system, then it will break out of that. And sometimes you might have to press multiple times Control C. But the point is that you understand why this infinite loop happened, because this for loop is working as it is, but you are saying that okay, I don't want to initialize with anything, I don't want to check for any condition, like every time just go inside, and I don't want to do anything else. So this is also, so this thing is completely equivalent to something like while true, and same thing. Both of these are completely equivalent. So this will also go in infinite loop, right? But I'm just saying the example I was just giving, that something like this is fine. You understand? and the example just came to mind because I was just trying to remove this first part. In fact, any part you can remove it, but then you have to take care. Like, let's say you're not incrementing anything, but then how you check that the progress is made? Otherwise it will again go in infinite loop. So here you can do so let's do that example first before going there. So let's say right now, let's comment this. So right now 0 1 2 3 4, let's say I don't do this I plus plus. Okay, then what will happen? Again, see, 0, it will print 0, and then you are not doing anything. You're not doing anything, and then you're again checking 0 less than 5. Yeah, again it will satisfy it. 0 print, and it will keep on doing because 0 is not incrementing any time, so it will again go in infinite loop, right? You can test that. See, again it is going in infinite loop, right? It went into infinite loop. So you can do something like that, but you have to take care it properly, that I know that I am not using it here, then I have to use it here. And why you want to use it here? Maybe that in some scenario you have complex logic of doing that. If something is there, then I want to do I plus plus, otherwise something I want to do I minus minus or something, whatever, some complex logic is there which you don't want to put here. In fact, you cannot put complex logic much here. Then you can do something like this. But if you are aware that what you are doing, then everything will work fine. So here also, see, it is working fine because I know that I am not doing anything here, but then I want to make progress, then I am making progress here only, right? So that is fine. Now let's see the thing which I was discussing earlier, that if I plus plus is there and this thing is not there, then here I was saying that you see that it was giving error that this outside this I is not defined, and if I move this I to here, okay, then you see that it is working fine. In fact, this last I, let's give an example, let's give an arrow here just to show that this is last part. If you see, this last part is 5. You understand? So basically I is equal to 0, it started, and whatever you are doing here, that you are doing, but now you are not doing in a variable which is specific to for. You are now doing operations on I, which is a variable outside this for loop. So whatever it is done after that. Not only this variable is still accessible here, because anyways it is accessible, it is in global scope, so it should be accessible. Not only that, but whatever you did here, everything, those changes are also available here. Why? Because that is a variable from here, and then I change it to 1 2 3, ultimately it came to 4, and for 4 it went inside. Outside, when it was coming outside, then it became 5, I plus plus 5, and then 5 less than 5 failed, so it did not go inside till 4 it printed. But now here I is 5, and that's why this last time this I5 is printed. Okay, so yeah, so this was just not only that. See, you could have done something like this also. I'm just giving you different possibilities. You could have done something like this also. Now this is also fine. Why? I declared a new variable. Yeah, I declared a new variable, but I initialized it. I did not create a new variable for the for loop, but I just initialized it. Okay, so I'm reusing the variable in outside scope. I'm not creating a new variable. However, mind you that again, like shadowing, with the same variable name you can declare a new variable inside the scope, inside a block, right? Similarly, right now it is like 0 1 2 3 4 5, it is working because this I is this thing. You can very well do something like this. And now what will happen is that this is undefined. You see why it is undefined? Because now the variable on which this for loop is iterating, that is a completely new variable, and this is sort of shadowing. This variable. So whatever this I plus plus is happening is on new variable, and that's why 0 1 2 3 4 everything inside this for loop is printed, but outside one is not changed at all, because whatever this I plus plus I'm doing in this variable, and that's why this is unchanged at all. And in fact that was like I was undefined initially, and that's why it is still undefined initially. If you could have initialized it with, let's say, 100, then it would be still 100. That is completely non-change, and this is a completely different variable which is going through 1 2 3 4 5, right? That is fine. Okay, so we saw scoping and we saw shadowing, right? In the next section we will see something called hoisting in the next video. For now, it's all for this video.